So here at the 2013 higher level DCG paper, and we're going to look at question A3. So question A3 is based around interpenetration, and interpenetration is when one solid intersects and goes through another solid. So what we have been given is a truncated pyramid, and we've also been given a prism, a triangular prism. So as we can see, the triangular prism cuts through this truncated pyramid. And don't forget, a truncated pyramid is just a normal pyramid with the top part cut off. So part A of the question asks us just to complete the plan, and we need to show all the lines of interpenetration. So a line of interpenetration is the line that is left when one solid cuts through another solid. And then we've been asked to use a section plane to find the crossover points on the edge D and C. So we're going to start over on the right hand side of the question. So it's very easy. So we're going to use again orthographic projection principles, where a point is in the elevation. So that's where the prism cuts through the pyramid. Where that point is in the elevation, it's directly below it in the plan. So we can see where we can see where point C stops. We can do the exact same thing with the line A and the line B. We know where it is and we know where it stops in the elevation, so it's going to be directly underneath it in the plan. We know that B joins to C, and we know that A joins also to C. So this is the line of penetration from A to C. And we also have the line of penetration from C down to B. And don't forget, there's also going to be a line of penetration where A goes to B. Now we know it's there, but we're not going to see it, so we're going to use hidden detail to highlight this. So that's all of the right hand side of the question done. So over to the left hand side, a little bit different. We're going to start off on the bits that we can answer straight away. So we can know where lines A and B stop. So B is going to continue in, and that's where it stops in the plan because it's directly underneath the elevation, and that's where the line A stops. We also know where C is going to stop. So C is going to stop there, and in the plan directly underneath C also. So just heavier than line C. So now we can see there's a turning point in the line of penetration. So we can see that's in the elevation. We cannot see it at all, it's just a line, but what I can do is draw a plane. So the question does actually give us the hint there. It tells us to draw a section plane. What I'm just drawing here is a horizontal section plane, or horizontal cutting plane. So I've cut through there. So what's that plane look like in the plan? So I know it hits the point on the prism there, so I'm going to bring those points down to the prism. So that cutting plane actually cuts through, shows us where the line E is going to stop, which is going to stop there. And the cutting plane also shows us where the line D is going to stop, which is there. So those is what we refer to as turning points. So line C joins up to the E line. That's one line of penetration, and now it goes all the way down to B, and that's the second line of penetration. So again, C is going to join to this D line, it turns, and then it joins down to the A line. And that is all of it, apart from, don't forget, the line of penetration from A to B again is a broken line, but we know it's there, so we're just showing it in. And that's all interpenetration is. So the sectional plane in the question, that will part give us the hit. So we can see there where the prism intersects into the truncated pyramid. So part B asks us just for determine the true shape of the triangle ABC. So the easiest part here is to go over to the right hand side again. We know that A and B, or the line AB, is on the ground. So I'm going to use that as my axis. And we're going to use a process called rebattement. So I'm going to use my rubber here as the line view. We rebat it onto the ground. So we have a line view. And then we have the true view of it, or the true shape of it. So it's inclined, it's rotated out, and we have the true shape of it. So how do we do that? As I said, the point AB is going to be my rotation point. So I'm just rebatting the shape ABC onto the ground. So now I have a line view, this line view ABC. So that's what it looks like. We're looking in at the elevation now. So bring it down to plan, and these points just fall straight out, as we saw with the eraser a second ago. So see, it's rotating, and I'm tracing the path off it with my finger. Don't forget, A and B do not move, because those are my pivot points, or my rotation points. So C is just going to join back to B, and C will join to A, and that is part B answered. We have determined the true shape of the triangle ABC. Again, it's always good practice just to help the examiner see what we've done. I'm going to put on just some rotational arrows, so I'm just allowing the examiner to see what I have done. And just back to A for a second, I've shown that my sectional plane has cut through the prism. I brought it out, showed where it cut through the prism in the plan. That's how I found my turning points.